Alright, in this lesson we're going to talk about pedigrees. Now pedigrees are charts to show a visual representation of inheritance. You've probably seen them before, they're a bit scientific family trees, but we're going to use some symbols so we can display some different types of inheritance, and then what you're going to do is analyse that inheritance to see what kind of traits are being passed on, or why, or whether it's autosomal dominant, or whether it's sex-linked. Right, so symbols that we're going to see, we're going to have a female, right, so I'll just draw that in there for you to remember, but we don't actually have to do that. Females are drawn as circles, males are generally drawn as squares, and if they display a particular trait we're talking about, we might be talking about a disorder like colour blindness, or we might just be talking about whether they're right-handed, then they are coloured in, okay, so you will actually see them coloured in. There is an alternate one here where you might actually see a half coloured in circle, and what that indicates is a female carrier. So in this case, because say the females have the two X's, one of them is the affected or the mutated gene or whatever it is, and the other one is perfectly normal. So they are not displaying the phenotype that we're talking about, but they do actually have one of those genes or those alleles that are indicating it. So what I'm going to do for you today is go and give you 3 generations of my family, right? So I am a female, we won't do any traits at the moment, but I'm a female here, and I'm actually connected to obviously my brother, all right, a male sibling there, and my parents will be up here in this generation here. So I'll put my mum on this side and my father on this side, and they are joined in this manner, one very straight line there, and that there shows that join there, and this is producing offspring. So my brother and I don't have the same join there, but my parents do. So if we then look at, say, all my parents' siblings, my mum has quite a number of them. She's got 2 sisters and 3 brothers, and they obviously have parents up here on that grandparents generation. So we've got that join again, and we've got my grandmother, my maternal grandmother, and my maternal grandfather. Same thing happens here. My dad has, well, he's got 3 sisters, so I'll have to squeeze them in. Didn't really plan ahead on that one. And obviously they have parents that have produced those offspring, all right? So you can see 3 very clear generations. You can see that the joins are very different as well. So we have to be able to distinguish between siblings and actual unions that are producing children or producing offspring there. And if we went through and said, okay, let's go that I am blue-eyed, my brother has blue eyes, my parents both have blue eyes, but my maternal grandfather has brown eyes. Let's say we're following the brown trait through. Both my dad's parents have brown eyes, so what we can indicate from that, what we can gain from that, is that if he is little e for the blue eyes there, so both parents are recessive, so that both children have to be recessive, they're the genotypes, so we know what the phenotype is. If we've got a brown trait that we're following through, we would have to kind of have a think that, right, maybe somewhere in there we've got heterozygous alleles so that we can produce these recessive combinations here, right? So they're the kinds of things you're going to do, is draw or create the actual pedigrees and then follow different traits through to look at the type of inheritance that it's being worked through the family with.